Hello and welcome back to another episode of Math with Sohn. Today we are going to be multiplying polynomials with other stuff. So multiplying polynomials is not complicated. You do need to go slow because you are going to have a lot to write down. We have to multiply the x in this case by all three terms. This is going to be a double distribution, so to speak. So x times all three terms makes x times 2x squared. That would be 2x to the third. X times negative 6x is negative 6x squared. And then x times 7 is 7x. And then you would multiply the 3 by all three terms. So I'm going to take the 3 and multiply by all three terms. So 3 times 2x squared is positive 6x squared. 3 times negative 6x is negative 18x. And 3 times 7 is 21. So this is, believe it or not, a smaller version of a problem because we only had 2 terms times 3 terms. We could have had more. Yeah. So if we are taking this from here, we have normally got some like terms. And in this case, we have 7x and negative 18x. Those are like terms. But we also have negative 6x squared and positive 6x squared. If we combine those, they actually go away. So we should be combining like terms, but we can't really combine something that goes away. It's just going to poof and go away. So I'm going to write 2x to the third. Then I'm going to write 7 and negative 18x combine to make negative 11x. And then I'm going to write my last term, which is 21 in this case. All right. So we got one more. This is an easier one. The next one I'm going to write down is going to be a little longer, but not much harder. It's just longer. So let's say we had x to the third minus 2x squared plus 1 times x squared minus 4x plus 5. So if you have 3 terms times 3 terms, you do not have to worry about the fact that this is skipping the x term. It's going straight from 2x squared to just 1. That part won't matter. But you will have to distribute the x to all 3 terms, that x to the third to all 3 terms. And then write them down. X to the third times x squared is x to the fifth because we add our exponents. X to the third times negative 4x is negative 4x to the fourth. X to the third times 5 is 5x to the third. Then we have to multiply the negative 2x squared times all 3 terms. So negative 2x squared times an x squared makes negative 2x to the fourth from these two. Negative 2x squared times negative 4, these two, is going to be equal to a positive 8x to the third. Negative 2x squared times 5, the last part, is negative 10x squared. Phew! Then you have to take the 1 and multiply by all 3 terms as well, which is a little easier because it's the number 1. 1 times x squared is a 1x squared. 1 times negative 4 is negative 4x. And 1 times 5 is 5. And then you end up with this huge long thing that you need to look carefully for any like terms that you may have. Starting with x to the fifth, do we have any other x to the fifths of any kind? No. So that's going to drop down, be x to the fifth. X to the fourth, we have 1 negative 4x to the fourth. We have a negative 2x to the fourth. And that's the only 2 we have. If we combine those, we end up with negative 6x to the fourth. And then we look at our 5x to the third. We got a 5x to the third here. We got an 8x to the third there. Those 2 combined. 5 and 8 make 13x to the third. And then we look at our x squareds. We got this x squared right here. And this x squared right there, negative 10 and positive 1 make negative 9x squared. And then you got your negative 4x, no other 4x's or 5x's or any x's for that matter, and no other regular boring numbers like the number 5. So we're going to just drop the negative 4x down and the 5 down and get this ginormous equation that looks like it belongs in a museum. All right, ladies and gentlemen, that's going to do it for this one. Be sure to check out the division for polynomials videos because those are by far what people struggle with the most.